Hey everyone, so these are the solutions to worksheet 1.5 on function arithmetic. Starting off with number 1, we're given two functions f and g and are asked to perform a variety of operations that involve combining the two functions and evaluating them. For part A, we're asked to find f plus g of 2. Now probably one of the first things we should do is think about what this notation means. The way that I like to think about it is really all we're being asked to do here is to find f of 2 plus g of 2. So that notation, both of these are equivalent. And at this point it's kind of easy to see, well, we know how to find f of 2. We go up to our function f, we evaluate it at 2. We can find g of 2 by going up to our function g, evaluating that at 2, and then we can just take the resulting value as our solution. So let's go ahead and do that. So if we were to take f of 2, and I'm just going to put these in brackets to keep them separate for now, but f of 2 would have us to take f, and in place of x we would put 2. And then for g, we would take our function g, and in place of x we would just go ahead and put our input 2. And now we can just calculate this value. So if we took this through, we would get 6 plus 1 plus 4 minus 2, which is just going to give us 7 plus 2, and then our solution here would just end up being 9. So that would be the value for part A. That would be our solution. For part B, we're asked to find g minus f of 1. Same idea. Let's go ahead and just rewrite this to get another idea. We could find g of 1 and then subtract f of 1 and find our answer that way. So again, we're going to go up to g, and if we take g and evaluate it at 1, we're going to have 4 minus 1, and then we'll subtract f evaluated at 1, which should be 3 times 1 plus 1. So that would give us 3 minus, and in this case we'd have 3 plus 1, which would be 4. So our answer would be -1, and that would be our solution for part B. Okay, for part C, same thing, except here we're dealing with f times g of 1/2. And we could think of this as f of 1/2 times g of 1/2. So this is going to involve some fractions, which will be a little bit interesting, but I think we can handle this. So we'll go ahead and we'll take f, and it's not on the screen right now, but remember that f was 3 times x. Here our input is 1/2, and then that was plus 1. And then we're going to multiply this by g evaluated at 1/2, which is going to be 4 minus our x value, which in this case is 1/2. Alright, so now some fun with fractions. So this is going to give us 3/2 plus 1. Just to kind of take a step here, let's think of 1. We're going to need a common denominator, so we can think of this as plus 2/2. And then this is going to be times 4, we could write as 8/2 minus 1/2. And now we can just do whatever simplification is necessary. In this case, 3/2 plus 2/2 is going to give us 5/2. And then 8/2 minus 1/2 is going to give us 7/2. And we multiply these two together, we're just going to end up with 35 divided by 4. And that would be our solution for part C. And then the last one for number 1, we have got f divided by g of 0. So let's think of this as f of 0 divided by g of 0. And then we'll just take f, which was 3 times x, which in this case is 0, plus 1, divided by g of 0, which would be 4 minus our input of 0. And we simplify this out, we're just going to end up with 1 over 4. So 1/4 would be our solution for that one. And that's how we would handle function arithmetic when we're given a specific value to evaluate it at. So for number 2, we're going to be doing a similar type of operation here, except we're going to be creating new functions as opposed to getting a specific value out of this combination of f and g. So for part A, we're asked to find f plus g of x. So there's no specified value that we need to worry about. So we could just think of this as, well, we need to find f of x plus g of x. So we've got f and g are both defined. So all we need to do now is write these, and I'm going to put them in brackets for now, but we've got 3x plus 1 for f, and to that we're going to add g of x, which is 4 minus x. Now in this case, since we're adding them, the only thing we really have to worry about is maybe combining like terms. So perhaps we could go ahead and combine these two x's, and then maybe we'll also want to consider combining the two constant terms. If we go ahead and do that, if we combine the 3x and the minus x, we're going to get a 2x, and if we combine the 1 and the 4, then we're going to end up with a 5. So this would be our new function by adding f and g together. For part B, we're asked to multiply these together, so we can just go ahead and say, well, what we're looking at is finding f of x times g of x. And then we can just go ahead and write those in there. So f of x we know is 3x plus 1, and then we're going to multiply that with 4 minus x, which is g. Now in this case, we're going to need to multiply out these two terms. So we'll multiply the first terms, 3x times 4, which is going to give us 12x, and that is an equal sign. Then we'll multiply 3x times negative x, which is going to give us negative 3x squared. Then we're going to multiply 1 times 4, which is going to give us positive 4, and then multiply 1 times negative x, which will give us negative x. So again, all that we did here is we multiplied the 3x times the 4, we multiplied the 3x times the negative x, we multiplied the 1 times the 4, and then we multiplied the 1 times the negative x, which gave us this. And we're almost done. Let's just go ahead and again look to make sure that we can't combine any like terms. In this particular case, we can go ahead and combine the 12x and the negative x. And that is going to give us the following. So I'm going to put the minus 3x squared out front, and then 12x minus x is going to give us plus 11x, and then we've got that constant term hanging on at the end there. So this would be our combination function for part B. And then lastly, if we go to part C, we're looking for the quotient of f of x with g of x. So this is going to be the function of f divided by our function g. And if we put f, which is 3x plus 1, all over our function g, which is 4 minus x, we double check to see that we can't factor anything out, maybe cancel it, but in this particular case, we've really done all that we can, and that would be our answer for part C. Now we move on to number 3. We're asked to calculate something called the difference quotient. The difference quotient allows us to we'll find out that it allows us to calculate average rate of change of functions, and more importantly, when you get into calculus, we'll see that this is a very integral part of the way that we define the derivative function. So it's nice to get some practice with it, and in terms of 1.5, it's great to get some practice just sort of combining and simplifying functions. So when we're asked to calculate this difference quotient, and it looks kind of like a mess, f of x plus h minus f of x over h. Don't worry about what the h is right now. Really what we're trying to do is just evaluate and simplify. So here's what I'd recommend that you do first. First, go ahead and calculate the term f of x plus h. We did that on a previous worksheet, but it's just evaluating the function. So we'll go ahead and we'll do that first. Once we get the f of x plus h, we can go ahead and use that definition to find and simplify the the difference quotient, which I'm just going to abbreviate as DQ. All right, so those are the two things that we're going to want to do. All right, so let's go ahead and try this out. So step 1, we'll find f of x plus h. So f of x plus h. We've got f of x right here, so all we need to do is now evaluate it at x plus h. So this would be 2, and in place of the x, we put an x plus h, and then we subtract 5. Let's go ahead and take this through. So we'll distribute the 2, and we'll get 2x plus 2h minus 5. And that's good. So we're just going to go ahead and we're going to leave it like that. So that's our f of x plus h, which is going to come in handy in the second step where we actually find and simplify the difference quotient. So the difference quotient has been defined for us as f of x plus h minus f of x divided by h. And aside from the h, we have everything that we need here. So first thing we're going to do is we're going to go ahead and plop in that f of x plus h we just calculated, which is 2x plus 2h minus 5. Now here we're going to, it tells us that we need to subtract f of x, and f of x we have up here. So now we can just go ahead and subtract our original function, 2x minus 5, and then this is all over h. Now inevitably there's going to be some simplification that is going to need to be done with these. One thing we could do is we could start looking through, if we were to distribute that negative, we'd see that we'd have a positive 2x and a negative 2x, so those are actually going to cancel out. We'd have a negative 5 minus negative 5, which would also cancel out here. So right off the bat, we've got a simplification that leaves us with just 2h in the top and then an h in the bottom. And also, since h is a factor of the top and the bottom, because it's a factor, these will also reduce down because it's just going to simplify to 1 essentially. So we're just left with 2, and that is our difference quotient. The simpler the function, most of the times the simpler the difference quotient is going to be. But we'll check out a slightly more complicated one in this last problem. So number 4, we've got a quadratic as our function f, and we're again asked to find the difference quotient. So let's go ahead and we'll fall back on the same 2 steps that we outlined in the first one. So first thing we want to do is let's go ahead and calculate f of x plus h. So we just take our function, and in place of x, we put x plus h. So we have 3 times x plus h squared minus, and we got another x, so we got to put another x plus h in there as well. We're definitely going to want to clean this up a little bit. So first thing that we do, order of operations, is we deal with that exponent before we distribute the 3. So we'll go ahead and we'll write that. If we multiply out x plus h squared, and I'm going to do this on the side just because, again, this sometimes is can be a spot for problems. If we've got x plus h squared, this is the same as x plus h times x plus h, which if we multiply out is going to give us x squared plus xh plus xh plus h squared, which simplifies down to x squared plus 2xh plus h squared. So that's what we've got inside here. So x squared plus 2xh plus h squared minus x plus h. Now we can go ahead and we can distribute through. So if we distribute that through, the 3 through, we're going to have 3x squared plus 6xh plus 3h squared, and then we also want to distribute that negative through to the x plus h at the end there. So it's going to give us a minus x and then a minus h. Nothing else can really be done in terms of combining things, so we can move on to the next step now. So for step 2, we want to actually go ahead and find and simplify the difference quotient. So we'll go ahead and we'll put the f of x plus h in there, which we just found out was 3x squared plus 6xh plus 3h squared minus x minus h. And we subtract f of x, which is 3x squared minus x, and this entire expression goes all over a denominator of h. Okay, so let's see what we can do to maybe simplify this. First, we're going to see if we can just cancel out any terms. Again, we've got a 3x squared and then this minus 3x squared over here. So those are going to cancel out. We have a negative x minus a negative x, which would be positive. So those are also going to cancel out. And when the dust settles on that first simplification, what we're left with is 6xh plus 3h squared minus h all over h. Now you can probably guess you're going to have to do another simplification step here, and you want to be careful about how you cancel that h out. What I'm going to do is I'm going to take the step of factoring an h out of the top, because h is a common factor of each of those terms in the numerator. So if I pull an h out, then I'm going to have a 6x plus 3h minus 1 all over h. Now, h is a factor at the top, h is a factor of the bottom, so they are going to simplify out because it just reduces to 1. And then we're left with 6x plus 3h minus 1, and that is our difference quotient, which we will find that we can use for average rate of change, and then also later on we can use this to help us find derivatives in calculus. Okay, so that's it for this video, and I'll see you all next time.